Chapter 5, Section 7. We're going to be looking at solving quadratic inequalities, both by graphing on a coordinate plane with x and y, and by solving the equations to get those answers. This is the beginning of the second half of the chapter. The first half we spent just solving quadratics using a variety of methods. We will still be using those methods in what we're doing today, but the new stuff it's different new stuff. It's generally easier new stuff. The hard stuff here we've already done before. That includes with just inequalities in general. We've worked with inequalities before. The same rules still apply. So, learning targets for today. I can solve quadratic inequalities using tables and graphs, and I can solve quadratic inequalities using algebra. That'll be with factoring, completing the square, quadratic formula, things like that. So, first thing, quadratic functions in two variables. That'll be different than quadratic equations, which are only one variable. So two variables would be something like y equals x squared. So anytime we're dealing with inequalities, though, remember there's two big differences. The first one is the line. Is it solid or dotted? The second one is shading. We have to remember to shade one side or the other. So first thing we want to look at is the line. We have two different types of signs. We have just greater than and less than, and then we have the or equal to's as well. Remember, just with lines and with points, greater than less than have dotted lines and open points, and the or equal to's have the solid lines and closed points. What are open points? Well, the open points are the little circles that aren't filled in, and the closed points are the circles that are filled in. As far as shading, how do we shade? We're going to plug in a point. Does it work? We shade the side that it works. The nice thing about quadratics is that it usually makes sense. It's either going to be above it or it's going to be below it, and it makes sense with the way the sign faces. So anytime we're graphing, I always have a couple recommendations. First, use graph paper. It's going to make it easier, quicker, neater, more accurate. And second, especially graphing inequalities, is use a pencil, not a pen. With pencils, we have the business end of the pencil. It's down here. That's the end that you use to graph. I don't know if you've noticed this, but if you flip it over, we have another end down here. And that is a dotted line maker as far as I can tell. Because a lot of times when you graph it, hey, I got it graphed, and then this next thought is, should that have been solid or dotted? If you're using pen, you're kind of out of luck. But pencil, you have a dotted line maker there to help you out. So let's look at graphing these things. Start out with an equation. Y is greater than negative 1/2 x squared plus 3. To graph something, let's make a table. Could you do this with transformations? Probably, but we'll make a table for this example. So we have our table, plug our value into the table, and find our vertex. Negative b over 2a, b is 0. Well, that makes everything else is just 0. Get a couple points on either side of it, and let's plug those into the equation. We've done all this stuff before. We're going to go through these steps kind of quickly because we've done it. Remember, when we square it, it's going to be positive. Then it'll be multiplied by a negative 1/2. So all of those numbers end up being negative at some point. Then add 3, and we get y equals 1, 2.5, 3, 2.5, and 1. Notice the symmetry there. And we can stick those into the equation or into the table. Once they get there, we're going to graph our points on an appropriate axis, and then we can connect the dots. And, oh, geez, that's right. Should this be solid or dotted? Nope, it's not an or equal to. We need to make it dotted. It's a good thing we have that capability. Then we need to shade. Plug in a point. If you plug in 0, 0, that's the easiest point. Is 0 bigger than 3? No. So we wouldn't shade that side. We can plug in 0, 4. Is 4 bigger than 3? Yes. And then, again, with the making sense, y is greater than the x squared, negative 1/2 x squared plus 3. It makes sense that we'd shade above the graph. And so that it's just the same as graphing quadratics with the addition of the inequality stuff that we've already seen, the solid or dotted line and the shading. So try this one. y is less than x squared plus 2x minus 5. So make a table, graph it, go ahead and pause the recording and push play again when you're ready to go. Think you got it? Let's check. So we need a table. We can find our vertex, negative b. That's negative 2 over 2 times 1. Negative 2 over 2 is negative 1. Get a few points on either side of that. Plug those into the equation, and you should get these values. If you're missing a value there, check your work on that. Make sure that when you squared the negatives, you got a positive. Then the 2 times the negative will be minus. We should get those values. We can plot those on an appropriate graph. Here we have a graph. Make our line. It's a dotted line because it's not an or equal to. And then shading, if we plug in 0, 0, is 0 less than negative 5? No, 0 is bigger than negative 5, so it'll shade on the other side. How'd you do on that one? Good? Bad? You need to go and check it? You need to ask questions? Post comment? Well, let's now look at quadratic equations. Quadratic equations only have one variable. So that's the stuff that looks like x squared plus 3x plus 2 equals 0. You can't graph that on a coordinate plane because we need that y. We need the second variable for that. So how do we solve these and deal with these? We can either use a graph in a table, and I'll show you how to do that one. After I just told you can't really graph them, we can make it work. Or we could use a number line. And so using a graph in a table, we'll look at 2x squared plus 3x plus 6 is greater than or equal to 5. When we're using a graph in a table to solve these, we're using it to help us solve the equation. Generally speaking, we're not going to be graphing these by hand if we're using it for this purpose. We're going to use a calculator. So how would you use this with a calculator? First, you'd want to put these into your graph, y equals. You want y1 to equal one of them and y2 to equal the other side. So we'll actually have two equations being graphed here. Once you have that, you can graph it, make sure your window setting is right, and we have a quadratic and we have a line. We want to know when our quadratic equation is greater than or equal to that line, that 5. Well, it's in two places. It's over here and it's over here. And so when does that happen? This is where you look at your table. If you go to the table feature, you can see that, oh wait, hey, equals 5 here, it's greater than it up here, it's also greater than it down here. That's weird. But if you look really close at the graph, you can see it dips down a little bit and then comes back up. On the table, notice we don't have that symmetry there. And so that tells us that we haven't actually seen our vertex yet. We can see one place where it's equal to. Let's adjust our table setting. If we're looking at the graph, it looks like, well, it's at -1. That looks kind of like -1/2. So let's go up by 1/2. So you can adjust your table setting to make the delta table, that's a change in table, be 0.5. That'll make it go up every half unit instead of every 1 unit. If we go back to the table, we see, oh, 5 and 5. There's both of them. It's bigger here. It's bigger here. We can see the symmetry now, 6, 6, 8, 8, which means the vertex would be right in between these guys at -0.75. But that's okay. We can see that it's bigger when x is less than -1 and when x is greater than -1/2. And so we get the two pieces of our answer. And it's because it happens in two different places. Well, that's using a table, and that works when it hits things like this. It's better when it hits on integers, but it's still kind of a guess and check. The graph is the guess. It gives you a great visual. It's always a good idea to make sure that you can check it, make sure it looks right, it matches your answer. But getting an answer that way isn't the best. So how else would we do it? Using algebra and a number line. So if we look at another equation, x squared plus 27 is greater than 12x. We're going to solve this like a quadratic. So first we want to move the 12x over. So we'll get x squared minus 12x plus 27 equals 0, or is greater than 0. In a little while, we're going to pretend that it equals 0, but right now it can stay greater than. First idea here is, can we factor this? Are there two numbers that will multiply to give us 27, add to give us negative 12? Well, what times what equals 27? 9 and 3? I think I can make a negative 12 out of those. So factor that. X minus 9, x minus 3 is greater than 0. Well, if x minus 9 is greater than 0, here's what we're going to pretend it's equal to. If x minus 9 equals 0, means x equals 9. If x minus 3 equals 0, means x equals 3. And so these are our two critical values. That's where it's going to change. That's going to be like the negative 1 and negative 0.5. We don't know which way it goes, and trying to figure that out from the equation itself with the greater than less than sign is kind of rough and sometimes tricky. What's easier is to put it on a number line and make a sign chart. This will be a useful skill in future classes as well. So if we make a number line, we're going to put 3 on the number line, we're going to put 9 on the number line. Now we're just going to pick values in these intervals and try them to see if it works or not. And so we can pick 0, that's less than 3. We can plug in 0. And when I plug in 0, I don't want to plug it in up here. I mean, 0 you could. I'm going to plug it in to the one where it's already factored, because I don't really care what these numbers are. I care about the sign. Is it going to be positive or negative? Is this one going to be positive or negative? I know that every two negatives multiplied together will give me a positive number. So if I have an even number of negatives, it'll be positive. If I have an odd number of negatives, it'll be negative. So let's plug in 0. 0 minus 9, 0 minus 3. Yeah, I know that's negative 9, negative 3, but who cares? It's a negative and a negative. You multiply two negatives, you get a positive. Are positive numbers greater than 0? Yes, they are. And so that means that this function will work when in this area, when x is less than 3. Then choose a number in the middle, 5. Plug it in. 5 minus 9, 5 minus 3. Don't care what the numbers are, but I know that 5 minus 9 is negative. 5 minus 3 is positive. If I take a negative number and a positive number and multiply them together, I'm going to end up with a negative number. And is a negative number bigger than 0? No, negative numbers are not bigger than 0. So it doesn't work in between 3 and 9. And then I can pick a number on the other side of 9. I can pick 20. It doesn't have to be close. People always want to try and pick like the closest number they can get. Pick a big number. Is 20 minus 9 positive or negative? Is 20 minus 3 positive or negative? They're both positive. When you multiply two positive numbers, you get another positive number, which is bigger than 0, and so it works there as well. So most of these are going to work either in the middle or on either end. If you get something like this where you get like 2 no's in a row or 2 yeses in a row, it might be time to check your work a little bit. But here we see that it works when x is less than 3. It works when x is greater than 9. So that's our answer. X is less than 3. X is greater than 9. That should not be an or equal to. That is a mistake. I apologize for that. That should just be less than and greater than. I wonder if I have a tool I can use here to change that. Pen. Look at that. Less than and greater than. All right. So, and I was actually about to mention that, like, when is it, like, this one's greater than or equal to, this one's not. It goes with the same exact sign. This one doesn't have an or equal to, the answer shouldn't have an or equal to. This one does, the answer does. All right, so let's take a look at another one that we can do on a number line. So here we're going to look at 3x squared plus 6x plus 11 is less than 10. It's a bigger problem than the last one. That's okay. We can deal with that. We're going to solve it just like a quadratic using algebra. So first step, subtract the 10 over. We get 3x squared plus 6x plus 1 equals 0. Here I changed it to equals. Here, instead of down a few steps, it doesn't matter. So looking at this, 3x squared plus 6x plus 1 equals 0. Can I factor that? Well, let's see, what times what equals 1? Well, it's 1 and 1. If I multiply 1 by 3, I'm not going to get 6. It does not look like I'm going to be able to factor this, and I'm not going to spend a lot of time trying to, because we have the quadratic formula. Just plug it in the quadratic formula. X equals negative 6 plus or minus 6 squared minus 4 times 3 times 1, all divided by 2 times 3. That'll simplify. 6 squared is 36, 4 times 3 is 12, 2 times 3 is 6, 36 minus 12 is 24, squared 24 is 4 times 6, so that gives us 2 root 6, and then we can split up our fraction to be negative 1 plus or minus root 6 over 3. Is it super important you do that? Not for the number, but it will help us, because now we can make a number line. Well, on our number line, we're going to have negative 1 plus root 6 over 3, negative 1 minus root 6 over 3. Which one of those is smaller? Obviously, it's the subtraction. When we subtract stuff, we'll get a smaller number. And when we add stuff, we get a bigger number. So now we need numbers to plug in. Well, first let's look at the number that will go in between them. What's in between negative 1 minus root 6 over 3 and negative 1 plus root 6 over 3? I don't care what root 6 over 3 is. The number in between those is going to be negative 1. We start with the middle number and we subtract a number and we add a number. Negative 1 is going to be in between there. So we can plug that into the equation. At this point, we weren't able to factor, so we'll just have to plug it into the top one. 3 times negative 1 squared, 6 negative 1 plus 11. We can simplify that. 3 minus 6 plus 11 is 8. Is 8 less than 10? Sure enough, it is. So here it works in the middle. Chances are it's not going to work on the outside. Let's try it. So we can find a number outside, negative 10. Negative 10 is one of those where it's not really close. It's going to be a long ways outside. It's perfectly fine. In fact, I would recommend that. Plug it in. We can simplify. We have 300 minus 60 plus 11 is less than 10. Oh, what is 300 minus 60 plus 11? I don't care. That is not less than 10. It's going to be 200 something. So it's not going to work for negative 10. It's not going to work when it's below that. Try a number above that. You can plug in 10, or and see negative 1 plus root 6 over 3. Root 6, that's between 4 and 9, so it's going to be between 2 and 3, so it'll be 2 point something. 2 point something divided by 3 is going to be a little bit less than 1. Negative 1 plus something less than 1 is still going to be negative. We could plug 0 in here, or we'll just go a little bit further just to be on the safe side. Let's plug in 1. 1 is easy to plug in, because 1 squared is 1, so we just have 3 plus 6 plus 11, which is 20, which is not less than 10. So no, that one does not work either. So kind of like we thought, it works in the middle. So you could have x is greater than the negative 1 minus 6x, and x is less than the negative 1 plus root 6 over 3. Or you can put it all as one compound inequality, where you have the small one is less than x is less than the big one. And notice it started out as less than. We still have less than. We didn't magically get or equal to signs. So have you try a couple of these? They probably won't be quite like this one, but it's a possibility. So try this. X squared minus 14 is greater than or equal to 2. How are you going to solve that? And don't do it by graphing. Do it algebraically. How are you going to solve it? Are you going to factor? You can use quadratic formula, or you can use the other method. Can you remember the other method? So go ahead, pause this, try it, and then push play when you're done. Did you get it? How did you figure out what x equals? I know that I would move this 14 over to x squared equals 16, or is greater than or equal to. Again, we'll pretend it's equals, and then just square root. Get x equals plus or minus 4. Plug it into your number line, negative 4 and 4. We need some values. Zeros in between them, negative 10, 10 are well outside, and then just plug them in. We have negative 10 squared is 100 minus 14 is definitely bigger than 2. Well, 10 squared is also 100 minus 14 is also bigger than 2. 0 squared is 0 minus 14 is negative, which is not bigger than 2. So here we have below negative 4 and above 4. So x is less than or equal to negative 4, or x is greater than or equal to 4. Notice when it's on the outsides like this, we don't write it as one inequality like we did when it was on the inside. All right, let's try one more. So try this one. X squared minus 4x minus 5 is less than or equal to 9. Go ahead and see what you can do on that one, and then push pause, push play when you think you have it. How'd that one go? Kind of got weird at the end, huh? So let's see what happens. We can move the 9 over, make it less than or equal to 0. And we can actually factor this one. X minus 2 times x minus 2, which minus 2 and minus 2, oh, those are the same. That's just going to give us x equals 2 for both of them. So if you make a number line, we only have 1 point on here. In the other two ones, we've had 2 points. We've had 3 different areas. Well, let's plug in some numbers. We can plug in 0 and 5. Plug in 0. It's going to be positive because negative times negative is positive. Plug in 5. Positive times positive is positive. And both of those positive numbers are not going to be less than 0. So we can graph it to see what it's looking like. It's like we want, when is this less than or equal to negative 9? Well, it's always above negative 9. It equals negative 9 right there. And if you remember the first problem, we had like a little decimal point, like it dipped a little bit. So let's just check the table. Looking at the table, we can see that, well, negative 9 is here, and then negative 8, negative 8, negative 5, negative 5. We get our symmetry, which tells us negative 9 is a vertex. That's going to be the lowest point, which means that the only time this will work is when x equals 2. X equals 2 is the only time that it'll be less than or equal to 0, or less than or equal to negative 9, depending on which equation you're looking at. So we get x equals 2. If it was greater than or equal to negative 9, it would be everywhere. It would be all real numbers. So when the vertex hits, it'll generally be an all or nothing type thing. And so just be aware of that. But generally speaking, you're going to have 2. If you get an imaginary number, it'll always be either everything or nothing, because it'll always be on one side of the line or the other. So that's all about solving quadratic inequalities in both things. Again, most of the hard work, the solving to figure out what does x equal, we have already done. Now it's just the what do you do with that number type thing. So I'll see you in class. Be ready for a quick group activity, and then you'll be starting your assignment.